Yes, a supposed comet is catching the attention of some of the nation's most renowned scientists, as one Harvard professor is raising the theory this may actually be a piece of alien technology.
An object traveling at 58 kilometers per second just entered our solar system, the fastest interstellar visitor ever recorded. But 3I Atlas isn't just breaking speed records. When astronomers first spotted it in July 2025, it was glowing far brighter than any comet should at that distance from the sun.
What if an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond?
Harvard's Avi Loeb is asking a question that has the scientific community on edge.
Presumably, if it had transmitted that signal, it had quite a powerful transmitter, about a gigawatt, according to my calculations, which is comparable to the power output of a nuclear reactor that we have on Earth.
Could this be technology rather than a natural object?
A mysterious object speeding toward Earth, and some actual bona fide experts think it might not be your typical space rock, or maybe any kind of rock, or a natural phenomenon at all.
The discovery that changed everything. Now, let's examine exactly what we're dealing with here, because 3I Atlas represents something strange that fundamentally challenges our understanding of what's possible in the cosmos. The discovery came through the Asteroid Terrestrial Impact Last Alert System, ATLAS for short, operating out of Chile through their Deep Random Survey Telescope. But at the time, ATLAS wasn't even looking for interstellar objects when it stumbled upon this object, 3I Atlas. The system was simply conducting a routine near-Earth asteroid surveillance when this cosmic intruder appeared in their field of view, moving with such incredible velocity that it immediately triggered every single anomaly detection protocol they had. When astronomers first analyzed the tracking data, they knew they were looking at something truly extraordinary. Its orbital eccentricity measures well above 1.0. What this means is that 3I Atlas isn't looping around our sun like planets do. It's moving too fast for that.
With 0 meaning it's a natural object, like a comet, for sure. And 10 meaning it's definitely a technological object.
Think of it like tossing a ball. If you throw it gently, it arcs back down. But if you launch it hard enough, it escapes Earth's pull completely. This thing is just passing through, but it's doing so on one of the most extreme trajectories ever recorded for an interstellar visitor. Before we dive further into that, let's zoom out and follow its path backward through space, through time, before it ever showed up in our skies. You see, this interstellar visitor was first spotted on July 1st, 2025 by the Atlas Survey Telescope in Chile. But even before that, pre-covery images from the Zwicky Transient Facility sometime in June helped pin down its motion. From that data came the shocking revelation. The trajectory of this thing is not bound by the sun's gravity, meaning it didn't form in our solar system and certainly won't stay. So where does it come from then? Based on its insane speed, traveling at 58 kilometers per second, and its incoming direction, astronomers trace its origin toward the galactic thick disk, a region above and below the flat disk of the Milky Way, populated by ancient stars and sparse material, where the dense stellar background made early detection nearly impossible. This crazy speed makes it the fastest traveling comet we've ever seen. It's as if this object deliberately approached from the one direction where Earth-based telescopes would have the hardest time spotting it until the very last moment. That alone suggests 3I Atlas is really old, possibly billions of years old. Some estimates put its age between 3 and 11 billion years. Now, astronomers have also checked whether any known nearby stars could have ejected this object in more recent times. Using data from Gaia, which tracks stellar positions and motions, they simulated possible stellar flybys going back millions of years. The result? No star close enough, moving slow enough, that really explains its current course. just a strange piece of space material flung out into deep interstellar space, drifted for eons, and is now barreling straight at us, and everyone is panicking more than ever before. So here's where the whole mystery deepens. The Hubble Space Telescope has been conducting intensive observations, capturing detailed imagery that reveals a brightness signature unlike anything in our astronomical databases. The luminosity profile they're measuring has an unusually steep gradient, steeper than what we observe in any known solar system comets. This brightness pattern alone is raising questions that strike at the very foundation of how we identify and categorize objects in space. Initially, the initial brightness measurements were so insane that multiple observatories had to independently verify the data. The Lowell Discovery Telescope in Arizona, the Canada-France-Hawaii facility on Mauna Kea, and Chile's Deep Random Survey all confirmed the same impossible readings, an object glowing far brighter than it should at its current distance from the Sun. The size of 3I Atlas. Here's where things get even more mind-bending. When we calculate the size of distant objects, we typically assume they're reflecting sunlight, according to some well-established models. Using these standard calculations, 3I Atlas would need to measure approximately 20 kilometers in diameter to produce the brightness levels we're detecting. That would make it absolutely massive. Potentially 40 times larger than our previous interstellar visitors, Oumuamua and 2I Borisov. Now, speaking of Oumuamua and 2I Borisov, let's help you understand this even better. The first time something like this happened was back in 2017, when astronomers spotted a strange cigar-shaped rock hurtling through our solar system. They called it Oumuamua, which in Hawaiian means a messenger from afar arriving first. And that name couldn't have been more fitting. Unlike anything we'd cataloged before, it didn't behave like a typical comet or asteroid. It didn't have a tail, no gas, no dust. It came in with an eccentricity of about 1.2, moving really fast, but not screaming out in terms of brightness or size. In fact, its trajectory and acceleration were so bizarre that some scientists, like Harvard's Avi Loeb, openly suggested it might even be an artificial object. Yeah, that's how weird it was. Then came Comet Borisov in 2019. This one, discovered by amateur astronomer Gennady Borisov, was more normal and predictable. Though its eccentricity is way higher than Oumuamua's, around 3.4, it still looked and behaved like a standard comet, only that it didn't originate from our solar system. It had the tail, the composition, and the volatile gases. Borisov was more like the control experiment, a proof that interstellar visitors could exist and still follow the rules we already knew. And now, enter 3I Atlas, the third interstellar visitor. And unlike the first two, this one doesn't really fit neatly into either category. Its origin direction is also different, approaching from near the constellation Sagittarius, from a direction that isn't aligned with what many models expect. It's not as bizarrely unexplainable as Oumuamua, but it also doesn't behave as predictably as Borisov. It seems to dance somewhere in between, challenging everything we thought were clear lines between asteroid and comet. That's why scientists are shifting in their seats. However, Avi Loeb and his colleague Eric Keto have made an observation that's sending shockwaves through the entire astronomical community. The brightness profile they're analyzing is consistent with something completely different. This object seems to produce a light of its own. Think about that for a second. If 3I Atlas is actually illuminating itself, then our size calculations are all wrong. We could be looking at an object that's hundreds of meters across instead of 20 kilometers. That's evidence of physics we don't understand, or technology we can't really explain. The statistical implications of this are simply staggering. According to Loeb's calculations, we see that finding a genuine 20-kilometer interstellar asteroid would be virtually impossible. There are very limited reservoirs of rocky material drifting between stars to deliver such a massive object to our solar system. It could only occur maybe once every 10,000 years. But for a smaller, artificially illuminated object, that's a whole game changer and opens possibilities that challenge what we know and understand about what's out there in the endless dark. What could make an object generate its own light? To understand how a space object could be self-luminous, the possibilities range from natural phenomena to artificial sources. Radioactive decay from heavy elements can cause it to glow. But finding just enough radioactive material in that sterile environment of interstellar space would be extremely difficult. Any natural radioactive source would need to maintain around 10 gigawatts of constant power output, equivalent to several large nuclear power plants running simultaneously for millions and millions of years. Now, thermal emission from internal heat sources can also be another possibility, but this would require the object to maintain temperatures far exceeding what solar heating alone could provide at its current distance. From the thermodynamic calculations we have already, 3I Atlas would need an internal heat source generating temperatures of over 1,000 Kelvin to produce that kind of brightness, temperatures that should be impossible for a natural object at 4 astronomical units away from the Sun. Now, this is where things get really interesting. So if none of these things could be the case, then it just could be artificial illumination from some form of strange technology beyond our current reality. The spectroscopic data pouring in from Gemini South and NASA's Infrared Telescope facility is where things start to feel less like simple astronomy and more like a science fiction mystery. What they found was unmistakable. Strong water ice signatures mixed with carbon-based minerals and silicates. Now, that sounds like normal comet stuff, right? But here's the catch. When you dig into the isotopic ratios of that water ice, it doesn't look like anything that should have formed here. It appears to be an entirely different stellar nursery, billions of years ago, far across the galaxy. In other words, this object could literally be carrying the fingerprints of another solar system's birth. A frozen message in a bottle, drifting for eons before stumbling into our neighborhood. So that evidence, which seems to point toward a comet, doesn't actually close the case. In fact, it might tilt things back toward the technology hypothesis in a way that's almost ironic. Imagine for a moment that 3E Atlas isn't a chunk of rock and ice at all, but some kind of ancient probe. Those icy layers and dusty coatings we're detecting, they could just be the interstellar dirt it picked up after millions, maybe billions of years drifting through space. Space is messy. Any object, even a machine, would end up looking like a comet if it wandered long enough. So instead of proving this thing is natural, the cometary evidence might be hiding something far stranger underneath. The trajectory beyond coincidence. Now, let's zoom out and look at the orbital mechanics. Because if you thought the chemistry was odd, the path this thing is taking will leave you wide-eyed in shock. Avi Loeb and his team wrote a paper bluntly titled, "Is the Interstellar Object 3I Atlas Alien Technology?" And they ran the numbers. What they uncovered rattles even the most skeptical minds. This object is on a retrograde orbit, meaning it's swimming upstream against the direction most planets travel. That's already unusual. But what's worse is the fact that its orbit is inclined only about 5 degrees from the ecliptic plane, the flat disk where our planets sit. The chance of that happening by pure randomness is barely about 0.2%. That's 1 in 500. And then comes the sequence of planetary encounters, like a cosmic trick shot that's almost too precise. On October 3rd, it sweeps within about 29 million kilometers of Mars. By October 29th, it hits perihelion at just 1.35 astronomical units from the Sun. Then it slides within 33 million kilometers of Jupiter. Statistically, the odds of one interstellar traveler hitting all three of those marks at that level of precision come out to about 0.005%, 1 in 20,000. That can't be anything close to luck. Now, you see, 3I Atlas hits its closest solar approach exactly when Earth is hidden on the other side of the Sun, meaning during the most critical window, we literally can't watch it. Solar glare blinds every telescope we have. If you were designing a craft to slip in unnoticed, that's the exact timing you'd choose. To Loeb, this looks suspiciously like a reverse solar Oberth maneuver, a clever braking strategy where a spacecraft could use thrust near the Sun to shed speed, possibly even anchoring itself in our solar system. And the best part? Earth's entire species of astronomers would be forced to look away at the exact moment it happens. The resistance and what it reveals. Now, of course, most of the scientific establishment isn't ready to leap into the alien explanation. The majority say it's just a comet doing its thing. David Jewett from UCLA, who's spearheading Hubble's observation campaign, points out that 3I Atlas is producing dust at a rate of 6 to 60 kilograms per second. That's right in line with what we expect from standard comets. The dust speeds, which are 20 to 2,000 meters per second, also match the usual playbook. So nothing here screams alien engines. Even the absence of certain volatile gases, like cyanogen or diatomic carbon, doesn't seal the deal. Remember, the object is still sitting about 4 astronomical units from the Sun, way out near Jupiter's distance. Most comets don't start spewing those gases until they dive much closer, when the Sun's heat really starts cooking them. So from that perspective, 3I Atlas could just be a late bloomer. And then there's the self-illumination debate. Some theorists have suggested that if the brightness anomaly isn't just a reflection, then maybe this thing is generating its own light. The problem? That would take around 10 gigawatts of continuous output. To sustain that for millions of years of interstellar travel, you'd need an absurd amount of fuel, or technology we can't even sketch out in our wildest engineering diagrams. For most scientists, that's where they draw the line. It's just too far-fetched. But here's where things get more intriguing. Even among skeptics, there's a quiet unease. Multiple astronomers have admitted off the record that while they believe 3I Atlas is natural, they still can't fully explain the brightness anomaly. They say things like, if the self-illumination idea ever turned out true, it would be the single most important discovery in human history. You can feel the tension. They don't want to plant their flag on alien tech, but they also can't quite put the mystery to bed. And that discomfort, that gap between the data and the explanations, is exactly why 3I Atlas has everyone watching so closely. Which brings us to the coming observation window. The next few months aren't just important. They could be the most decisive period in modern astronomy. As 3I Atlas creeps closer to the Sun, it should start showing those cometary emissions if it really is a comet. If it doesn't, well, that's another strike for the Team Natural camp. The James Webb Space Telescope has already cleared its calendar, lining up to measure the object's infrared profile in exquisite detail. That means we'll soon know more about its temperature and energy output than any interstellar visitor in history. But the real fireworks may come from Mars. In early October, as 3I Atlas brushes past, NASA's Mars Reconnaissance Orbiter will attempt to capture high-resolution images using its high-rise camera. Just think about that for a moment. For the first time, we might get an actual close-up of an interstellar object's surface. Now, with those pictures, we might finally answer whether the light we see is sunlight bouncing off ice or something glowing from within. ESA's Mars Express and the ExoMars Trace Gas Orbiter will also join the show, creating a coordinated 3D view of the object from multiple perspectives. But timing really matters here. When 3I Atlas is nearest to Mars, it's still far enough from the Sun that natural and artificial light signatures can be teased apart. Once it dives closer, the solar heating could muddy the signals, so that October window is simply priceless. A fleeting chance to solve the riddle before physics itself smears the clues. The implications that kept scientists awake. Now, let's pull the lens back to the big picture. If the artificial hypothesis is right, and 3I Atlas is a machine, then we're staring at something that's not only glowing, but also flying a perfectly calculated trajectory, slipping past 3 planets, dodging Earth's gaze, and maybe even hitting the brakes to linger in our backyard. And it forces questions that are hard to even wrap your head around. Why arrive during solar maximum, when detection is hardest? Why time the perihelion when Earth can't observe? Why skim past Mars and Jupiter as if on a survey mission? These aren't random moves. They feel like a strategy. NASA's own OITS software, the same tool used to plan real missions, has run simulations. And here's the unsettling result. If 3I Atlas had even modest thrust capability, it could alter course and remain trapped in our solar system indefinitely. Just think about that. Something coming from the galactic deep and then deciding to stay. Of course, maybe it's natural. Maybe it's just a bizarre outlier that exposes gaps in our physics textbooks. But whether it's alien or not, the lesson is the same. Our universe is stranger than we think. The Vera C. Rubin Observatory, which has only just started its full operation, is expected to find dozens more interstellar objects every single year. That means soon we'll have enough data to know what's normal and what's truly rare. 3I Atlas might be the canary in the coal mine, the one that shows us how little we actually understand about interstellar wanderers. The countdown. And here's the ticking clock. Astronomers call the next stretch the point of no return. If 3I Atlas can maneuver, it has until early November to make its move. After that, its hyperbolic trajectory will sling it out of the solar system forever, never to return. October's Mars encounter, the hidden perihelion behind the Sun, and December's Earth flyby. 3 solid key checkpoints. Each one is a chance to catch it in the act, whether it's outgassing ice or firing engines. After that, the curtain closes. But here's the detail that keeps researchers awake at night. What if, really, this thing was timed deliberately? What if it were launched to arrive during this exact era, when our technology is just advanced enough to notice it, but too primitive to stop it, chase it, or even talk to it? If so, then we might be up for something truly unprecedented. Stack up the coincidences, approaching from the galactic center during solar maximum on a retrograde orbit aligned with our planetary system, hitting perihelion when Earth can't see, glowing in ways that don't quite add up. 1 or 2 coincidences you can excuse, but when the list gets this long, even hardened skeptics start to sweat. Either nature is capable of bizarrely orchestrated magic, or someone else is writing the script. And that's why 3I Atlas matters, because in the next 3 months, we'll either confirm that our universe occasionally throws dice with impossible odds, or we'll learn we are not alone. Both answers are seismic. Both change what it means to be human. Even if it proves natural, the lessons will ripple across science, forcing us to rethink how interstellar bodies form and behave. If it's artificial, then history divides neatly into before 3I Atlas and after. Either way, astronomy will never be the same. and we just aren't ready for it. Ready for more groundbreaking discoveries about our galaxy and beyond? Subscribe now and stay ahead of how humanity's future is being shaped by these cosmic revelations.